It's my pleasure to introduce Chloe Seeborg. She's part of my team too. Welcome, Chloe.
Hi, everyone. My name is Chloe Seeborg. I work for Melanie's USU Small Farms Lab as a research technician. Today, I'm going to be talking about how you can calculate Dahlia water needs using free weather station data. Our goal with this study was to determine the irrigation needs of Dahlia. There is currently a lack of research into cut flower irrigation and a need for research to determine irrigation rates that balance stem production and water conservation. We chose Dahlia because it is one of the most popular and profitable cut flowers in Utah. It's a sensitive crop that is easily stressed if it doesn't get just enough water or nutrients. It prefers a narrow range of temperatures and is also prone to virus infection. Water and temperature stress already make Utah a challenging growing environment, which is compounded with Dahlia's sensitivity. The field trials took place during the 2023 and 2024 season at the Greenville Research Farm in North Logan, Utah. The field was zero point 0.2 acres with a silt loam soil. We chose two cultivars, Boom Boom White and Cafe au Lait. We had a total of 500 plants, so 250 of each cultivar. We chose Cafe au Lait because it is the most popular dahlia in Utah and it's very sensitive to stress and viruses. It produces these large dinner plate blooms that don't start until later in the season, so if management isn't optimized, then blooming is delayed even further. Boom Boom White was our insurance policy cultivar because it is more robust than Cafe au Lait. It also represents a different bloom type, which is decorative and is popular for wedding arrangements. We tested 5 different irrigation rates using the water needs of alfalfa as a baseline. The first group received the same amount of water that alfalfa needs, or 100%. If you're not sure what that means, that's okay. We're going to talk about what 100% of alfalfa's water needs means and how to figure out that number, so stay tuned. To test the response to less water, we also tried 80% and 60% of alfalfa's water needs. And finally, we had two groups that received either 80% or 60% irrigation until bloom, and then were switched to 100% for the rest of the season. One way to figure out plant water needs starts in the soil, where we measured soil moisture. We had 40 sensors like these ones throughout the field, with 30 at a 3-inch depth and 10 at an 8-inch depth. Knowing the amount of water in the soil, along with the amount of irrigation water applied and the amount of rainfall, it's possible to determine plant water use, which is called evapotranspiration. And knowing the amount of evapotranspiration is incredibly useful because it tells you how much water needs to be replenished by irrigation. This method is great for making sure your plants get enough water, and it takes the guesswork out of finding the balance between underwatering and overwatering. This diagram at the bottom shows the components of evapotranspiration, which I'll be abbreviating as ET from now on. So this arrow represents the water that evaporates from the soil surface, and then this arrow represents the water that transpires out of plant leaves, which is water's eventual destination after it gets sucked up by the roots and travels up through the plant. Because we're doing research, we can monitor the soil with a lot of instruments. However, determining crop coefficients makes it possible to calculate irrigation needs for free and without using any sensors. Crop coefficients are numbers that are used to adjust the water requirements of alfalfa to any crop. And since water needs change throughout the growing season, crop coefficients are determined for each growth stage, which are establishment, vegetative, and reproductive. So weather stations throughout Utah calculate and report the ET of alfalfa. So we use that data along with the ET that we calculated for dahlia using all of our sensors to determine how much water dahlias need in relation to alfalfa as a reference, which is exactly what a crop coefficient is. So let's look at some ET data. This comes from the Utah Climate Center, and you can access ET data for free on their website, which is climate. This is what the weather stations look like, with the Murray weather station shown here, but this is just one of over 100 throughout the state. This table is filled with the 10-year average of the weekly ET of alfalfa for each month throughout the growing season. Notice how water use increases as we move into summer and then decreases again as fall approaches. ET increases with the increasing temperatures in the summer and also increases when it's windy. You'll see decreased ET on cloudy days or rainy days. To get an idea of how much ET happens per day, we can divide these values by 7, which gives us about 0.2 inches per day in April and May, 0.3 inches per day in June, July, and August, 0.2 inches per day in September, and 0.1 inches per day in October. Now let's look at the results from our study, and let's start with the growth stages. Remember that separating the season into growth stages helps us tailor irrigation to what the plant needs at that time. So the first growth stage lasts for the first 3 weeks after transplant. We transplanted after the last frost date, which was the last week of May during the study years up in Cache Valley. While the plants are still small, they require the least amount of water, which for Dahlia is about 70% the water needs of alfalfa. The next stage starts in the summer and goes until the plants are budding. And during this stage, the plant is continuing to leaf out and grow, so water need steadily increases up to 100% the water needs of alfalfa. Finally, the reproductive stage starts at flowering and lasts until the end of the season. At this stage, plants have the highest water demand, with Dahlia requiring 115% of alfalfa's water needs. For yield timing, we found that more water led to earlier blooming. In 2023, the fully irrigated plants bloomed up to 2 weeks sooner than the lowest irrigated plants. It was the same in 2024, with the well-watered plants blooming 3 to 7 days sooner. In an optimal year, the average number of days from transplant to first harvest for the fully irrigated plants was 82 days for Boom Boom White and 97 days for Cafe au Lait. If you are in a year with less favorable weather conditions, it will take longer to reach your first harvest. We also found that the fully irrigated plants produce the most marketable stems. This increase only goes up to a certain point, leveling off at just a little over the water requirement of alfalfa. After that, there isn't a benefit to using more water. So in 2023, the fully irrigated plants produced 6 more stems per plant than the lowest irrigated plants. Similarly, in 2024, the well-watered group produced 3 more stems per plant compared to the least watered group. There were factors other than irrigation that impacted our yield results. Specifically for Boom Boom White in 2024, the plants really struggled with virus infection, and extreme temperatures were a problem for both cultivars in 2024 as well. At the end of the season, the tubers were dug up and weighed. We found more water resulted in heavier tubers. The tubers that received 100% irrigation were 0.4 to 0.6 pounds heavier than those in the 60% irrigation group, which is 14 to 44% heavier. We also found that the tubers produced by Boom Boom White were twice the weight of the Cafe au Lait tubers. This graph goes from mid-June to early October, with this blue line representing the crop coefficient that we calculated for Dahlia. You'll see that it steadily increases during the vegetative stage, which is noted by these brackets at the top of the graph, from a value of 0.7 to 1. Then the switch from the vegetative to the reproductive stage happens when the plants are budding, which looks like this. And up in Cache Valley, we found on average it was the end of July and early August when that switch occurred. So during the reproductive stage, the crop coefficient reaches its max value and maintains that value for the rest of the season. And the value is 1.15, which means that the plants require just a little bit more water than alfalfa does. And it's important to not water stress the dahlias when they're blooming. The transplant stage is just off to the left side of the graph, with our transplant dates happening on May 22nd and 23rd in 2023 and May 30th in 2024. This stage has the lowest water requirements with a value of 0.7. Okay, we're going to switch gears now. It is your turn to participate. I'm going to walk you through how to access ET data from the Utah Climate Center. So the website is climate.usu.edu, and when you get there, you'll click UCC Mesonet and then click All Network Map, which will pull up this map here. You'll see that there are around 140 weather stations in the state, so you should be able to find one that's close to you. You'll zoom in on the weather station. We're going to stick with the Murray weather station for our example today. You'll click the station and then click View Station Data. And you'll be able to access these slides afterwards, so don't worry about trying to keep up with me. You'll have access to these instructions later. So once you click on your weather station, you'll be redirected to the web page for that station. I would suggest bookmarking this page so that you can access it easier in the future. So there's a lot of information that is displayed here, but what we're interested in are these data charts. So you'll have to scroll down to the bottom of the page to get there. And the units will be in inches by default, but if you're a nerd like me, you can choose to look at it in metric. So you'll want to select the reference ET chart and switch the chart to daily. The line that we want to focus on is this red line. It's labeled ETR, which is the abbreviation for evapotranspiration for alfalfa. The orange line is ETO, which is evapotranspiration for turfgrass, which is also used as a reference crop. But for cut flowers, we're really going to focus on the alfalfa reference. So this graph is the daily ET for the Murray weather station for the month of July in 2025. And as you hover over each of the points, the ET for that day will be displayed. You'll see that it stays pretty consistent throughout the month at a value of about 0.35 inches per day. And it's possible that these dips could be cloudy days, rainy days, or just days with cooler temperatures. And this peak here is probably a warmer day or probably a really windy day. So now that you know how to access the ET information, we can put everything together to determine irrigation amounts. First, you'll use your favorite weather service to look ahead for the week. This is a 10-day weather forecast from the Weather Channel. If the forecast is similar to the previous week, you can assume the next week's ET will be about the same. If your forecast shows more than a 5 to 10 degree difference, rain, or a lot of wind, then your ET will be different. So let's see the crop coefficients in action. Your first step is to add up your estimated ET from alfalfa for the week. So if you're estimating about 0.3 inches per day, multiplying that by 7 gives us 2.1 inches of ET for the week. Then you're going to multiply that total by the crop coefficient for the current growth stage. So if the dahlias are in bloom, then you'll use the crop coefficient for the reproductive stage, which is 1.15. So continuing with our example, we'll take our 2.1 inches of ET for alfalfa times our crop coefficient, which gives us 2.4 inches of ET for the dahlias. And voila, you now have the number of inches of irrigation to apply that week, which you can divide into individual irrigation events. If you're watering 3 times per week, then you'll take your 2.4 inches of irrigation water, divide it by 3 to get 0.8 inches per irrigation event. To translate inches into gallons, you will need to know the fed area, and you'll also need to use the conversion factor, which is 0.623 gallons per 1 inch of water per square foot. So for this example, we'll have a 4-foot by 10-foot bed, which multiplying these together gives us a 40 square foot bed area. So we'll take 40 square feet times our 0.8 inches of irrigation times our conversion factor to give us 20 gallons of irrigation water per irrigation event. Now, the last step is to translate gallons of water into amount of time to irrigate. We don't have time to go through that today, but if you are interested, you can come to our summer field day with your irrigation specs to learn how. Here are some things to consider when deciding how often to irrigate. First, during the establishment period, you're going to want to water more frequently so you can keep the soil surface moist. This is because the plants have a really shallow root system at this point and they are very sensitive to water stress. During the USU trials, we sometimes irrigated every day, but just a little bit to keep the near surface moist. Soil texture is another important factor to consider when deciding irrigation frequency. In the USU trials, I mentioned that our field was a silt loam soil, and we irrigated 3 times per week each Monday, Wednesday, and Friday. If you have a sandy soil, you'll want to water more frequently and water clayey soils less frequently. You're still applying the same amount of water for the week. It's just the number of irrigations that you divide that into that changes. All right, let's wrap things up. Access your local ET information at climate.usu.edu. It's free. And use ET and crop coefficients to take the guesswork out of Dahlia irrigation. The crop coefficients that we determined for Dahlia are 0.7 for transplant, 1 for vegetative, and 1.15 for reproductive. And there's currently limited information on the crop coefficients of other cut flower crops, but alfalfa is a good reference for many cut flowers. You can type in the chat what cut flowers you would like us to see study next. Thank you so much for your time and your attention. You can access these slides at diverseag.org. And if you're interested in coming to our field day, here are the irrigation specs that you should bring. Again, thank you so much for listening.
Thank you, Chloe. That was a wonderful presentation about the most complex study that we've ever done in
Yeah,
our lab at the farm because it's managing all these different irrigation rates, a lot of physics, 500 plants with unique personalities as well as health status. So we're grateful to
yes.
Claudia for helping on that end too. And so you're able to keep track of all of that. So hopefully you guys can attend our field day. We're trying to develop an irrigation calculator based on the specs that Chloe has written here on the slide. So come ready with those and we can translate how much we're watering by time into inches and gallons at the field day and then relate that back to ET. So I'm going to take a look here at the Q&A. Chloe, I think it's fine to keep your screen up for another couple minutes, but then a minute before if you want to unshare, that'll allow Claudia to get set up for her talk. So there is a question about what station has data for Sandy City, and I know that there's participants here from all over Utah. Could you maybe go back and just show how many stations we have and where you would find out where your nearest one is?
Yes.
And then Chloe had the question about what flowers would you like us to study next for irrigation? We studied the thirstiest flower in Utah, so feel free to throw it in the chat. What are your suggestions for us for next time? All right, back to you,
So
Chloe.
yeah, here is the map of all the stations. So you'd have to zoom in. Actually, on the bigger picture, the second picture of the map, you can see Sandy is actually on the map here. So it's probably the weather station just to the right. Yeah, so this is the Murray one, but there is one that's even closer that could be useful.
Excellent. Yeah, so that's one amazing resource that we have here at Utah State is just the number of weather stations so you can really dial into your local conditions. Um, so we've been plugging a field day and no date for it. It'll be this summer and we will announce when that field day is, but probably in July or August, be most likely. There's the next is to ask about zinnias and what their water demand is, and that's not so fair to Chloe, so I will just step in if that's okay. We know that zinnias require less water than dahlias, of course. They're a more drought tolerant one. And so when Chloe was talking about the crop coefficient to use with alfalfa, we actually ran zinnia. It's what the first crop I worked with at 80% of ET, so at 0.8 through the season, and that worked out pretty well. And we probably could refine that a little bit more earlier on, but 0.8 was about their crop coefficient. So thinking about Dahlia, that gets up to 1.15, you can see that there would be a bit of a water savings with something like zinnia. All right, so there's another question on freesia, and we can take a look at the Q&A here as Claudia gets started, but